Hello learners, welcome back to MS2012 Ecosystem and Natural Resources, which is the second course of postgraduate diploma in sustainability science. In the last few sessions, we have talked about the different kind of natural resources, energy and so on. Now we know that we are utilizing resources, energy or whatever the resources with us, around us. At the same time, we are also exploiting the resources, and we know that resources have limited stock. If we look into long term also, now it's a threat to ourselves when we do not have any resources. So today in this session, let us have a quick look into how we have to conserve the resources and the energy. It will be in two sessions. In the first session, we are going to look into some of the related concepts when we are trying to understand that ecosystem from the lens of sustainability. And we know that we take an overview of better ways of managing natural resources when we are trying to understand the sustainability of a system. Many of the natural resources, they suffer from depletion, which is a situation which occurs when a resource is utilized faster than it is replaced by natural processes. For example, the material resource deposit, as we call it, mineral or oil, it took millions of years to form. But when we look into the way we are extracting, the way we are consuming, it's in just a few years only. On the other hand, for example, we have few species that took many thousand years to evolve. Then in another few years or another one decade or 1 century, it drives to extinction very easily because of our activities. So the ideal goal of resource management, is sustainable resource use. That means seeking to conserve or slow down the rate of resource consumption to the point where a resource can be replenished by nature. We know harvesting of trees or fishes or other biological organisms, we harvest, cut the trees, we harvest the fishes and all these things by looking into their stocks. In another case, if the resource is in immediate threat of disappearing, sustainable management must follow the principle of preservation, where the exploitation is totally stopped so that the resource get time for regeneration or attain resilience. For example, when you talk about when we are studying about diversity in another session of the same course, like endangered species and the endangered ecosystem, right? We also know that stopping or slowing down the rate of resources we use not only slows depletion, but it really has an added advantage of minimization of the waste produced out of the resources we use. So on the other hand, on the same time, it also reduces the pollution. So the point is that when we are trying to develop a sustainable society, and a sustainable society practices throughput reduced to the point where exploited resources, means the inputs we are taking as stocks get enough time for regeneration by natural processes, and the pollution means that is output, which is the output of process of utilizing the resources that remain under the accumulation capacities of the resource base. However, if you look into the conventional ways of resource management, then that is very difficult to achieve this goal of sustainable use, as they are more influenced by the short-term benefit of society, economic and political gains, that emphasize more looking towards rapid exploitation of resources. So today's session, we need to understand that when we are trying to look into a process of sustainable or conservation of resources, first we need to understand and aware about some of the environmental perspective of laws of energy and matter in different systems like biological system, and how resource depletion is happening and what are the conservation of resources. when we talk about, before looking into how we have to look into the conservation of energy in the resources, first we need to look into what are the environment perspective of the natural laws of energy and matter. When we talk about the energy, we know that we have first law of energy or first law of thermodynamics, as we call it as a law of conservation of energy. There it talks about, it talks that there is no way in which one can get more energy out of a system than the input energy. Since, this first law of energy or first law of thermodynamics says that energy quantity, the input energy equals to output energy. There is no loss of energy. Similarly, that is exactly what the first law of energy is saying, that energy never lost. Similarly, when you talk about second law of thermodynamics, it's also called a second law of energy. It suggests that we lose some useful energy every time some work is done. So, but again, from the first law of energy, we cannot lose energy. Then what we lose? In the first law, it says that energy is not lost, or we cannot lose energy. But in the second energy says that some energy is lost. So it is the quality of energy, the amount of energy available for performing a useful work, right? For example, when fuel oil is burned in a machine, it is partly converted into mechanical energy, then into electrical energy, into light energy, and chemical energy of the exhaust emission extra. But a major part that is converted into heat energy gets lost into the atmosphere, remains of no use. From this example, we understand how second law and first law explain it. Again, in another example, in an engine, you will see only about 10% of the high quality of energy of fuel oil gets converted to the mechanical energy and electrical energy. Only 5% of this electrical energy lights the bulb. The rest 90% in first step and 90% in second step are low quality heat energy into the environment. So thus, when you talk, when energy is changed from one form to another, some of the useful energy is always degraded to lower quality. So more dispersed and less useful energy being lost in the form of heat given off at a relatively low temperature to the surrounding environment. So the more we use, the more low grade energy we add to the environment, and we can never recycle or reuse that higher quality of energy to perform useful work. So we can heat air or water to bear high quality energy, but at the cost of more high quality energy, right? So again, when you talk about the matter also, if you look into some of the laws related to matter, say for example, according to law of conservation of matter, it says that under ordinary circumstances, matter is neither created nor destroyed, except nuclear reaction, but it recycles endlessly. Matter is transformed and combined in different ways, may get dispersed and go somewhere, but it doesn't disappear. As we use more resources to produce more disposable goods, we end up converting high quality matter into low quality matter. So high quality matter is generally more organized, concentrated, usually found near Earth's surface, and has great potential for use. But when you talk about when low quality energy, it is disorganized, diluted, and often found deep underground or dispersed in the ocean or in the atmosphere, and usually has little potential for use. Like when you talk about the foils, metals, drinking water, etc., they are high quality matters, and the ore, pollutants, impure foils, impure water, they are low quality matters. So the useful goods that we produce gradually become low quality matter, that quality matter depending upon its durability. Then again, for example, when you talk about the foils, right? Once it used, gets converted into low quality matter. When we deal with disposal or treatment of waste, we again use more high quality matter. Again, the low quality matter that's generated has to go somewhere, right? Like some of the persistent pesticide and toxic metals have the tendency to form the cycle of poison when enters the food chain through polluted habitat. Thus, when you talk about a pesticide, say dichlorodimethylchloride, that is DDT, that band at some place diverted to other, that reaches everywhere as residues even across ocean and to fall out from your masses. So nowhere we can get rid of our misdeeds. The result return back to us in one form or other. As the quality of a matter depends on its usability, recognizing the utilities potential of those resources, the harnessing may reduce the amount of low quality matter generation. Then, when you look at the law of those energy in matter in a biological system that govern in nature, less than we know about 10% law of energy and so on, right? That we have all this study in here when we study the trophic chain and the food chain system, right? So in that, less than 1% of solar energy is trapped in the process of photosynthesis by the plants. The food that goes to the consumer is only a part of total photosynthesis, and again only around 10% of the total intake as food gets assimilated by the consumer. And at last, during the process of conversion of molecule, that muscular energy into mechanical energy, a great amount of energy gets lost. The uniqueness of biological system governs in nature, that is, the energy input is perpetual, means the perpetual energy, what is that perpetual energy? That is solar energy, and they need the chemical elements, not in very concentrated form. So, autotrophs are simply the natural instrument for trapping the perpetual flow of energy. In the same time, we know that about these laws, and we use all these resources in one or other form, and from utilization in some resource we utilize in some other way. When it is beyond the utilization, that calls exploitation. And in that way, that resource depletion is happening as we are aware that. So all out of those two basic inputs, what we are talking about, matter and energy in the environment, right? In that, you will find out that matter constantly cycle, right? Where when talk about the energy resources, they primarily has a unidirectional flow. That is why the reason why matter energy are depleted differently. So, depletion of matter resources and depletion of energy resource needs to be understood in a simple way. And what is the difference? Let us have a quick look into that, and about the bubble pattern of resource depletion. That is one of the major characteristics what we have seen in front of us. So when we talk about depletion of matter resources, when we talk that matter resources, they are depleted by being lost or dispersed. For example, ore deposits are actually concentrated deposits of minerals that are normally found in more diluted form in the earth crust. When the ores are mined out and processed into pure metal and then to different products, the atoms may be eventually dispersed due to wear and tear or lost to the further human use when the products are disposed of in a landfill or elsewhere. Similarly, when you talk about the rapid erosion of the soil, that is not because of the nutrients, minerals in the soil, they are also destroyed, but that is because the soil is dispersed ultimately in the soil, right? So, these are some of the examples that shows when non-renewable resources disperse molecules of metals and soils stay dispersed unless we spend much energy and money to reconcentrate them. On the other hand, dispersion of all these potential renewable matter resources such as timber also occurs, then we can regenerate them relatively quickly. Potentially renewable matter resources often biologically in nature. When you talk about depletion of energy resources, we know that energy resources get depleted whenever they are subjected to conversion to different form. This is the key difference from some form of laws when we talk about matter. When in case of matter, we know that it could be recollected and reconcentrated if society has enough energy. In contrast, in case of these energy resources, once energy is transformed, it is lost forever. Waste heat can never be reconcentrated. If we burn oil or coal to release their chemical energy to drive an engine, that energy can never be used. We know that we have a measure source of renewable energy. If we have these issues also, like we are utilizing the sun, which is one of the major source of renewable energy, and then we have solar power, biomass, hydropower, and wind, so on, right? Then, what exactly is the bubble pattern of resource depletion? This phenomenon, we are very common with us, those who are in the area of energy study and the energy crisis. We know the unsustainable use of many resources that exhibits a bubble pattern of depletion. This is the best known example, that Hubbard bubbles. Then the best example is when we have oil depletion in 1970. That's Hubbard bubbles of oil depletion has become one of the examples which we clearly understand this pattern, bubble pattern of resource depletion. In fact, it was named after King Howard, who accurately predicted the bubble pattern of oil depletion in the United States, right, in 1970s. This bubble pattern has two main causes. One is exploitation, another is depletion. Both this exploitation and depletion are following an exponential pattern which tend to form a mirror image of each other, with exploitation on the left side and depletion on the right sides. Resources, we know, are exploited very quickly once society discovers their utility. So, exponential demographic means your population plus technology. This exponential demographic growth is the main cause of exponential exploitation and the exponential phase that continues as long as the supply exceeds the demand. But because of all non-renewable resources on earth are finite, limits to growth eventually occur and demand begins to exceed supply. So during this time, society usually intensifies its efforts to obtain more of the resource through technological application. However, all those efforts usually soon encounter what most of the economists call the law of diminishing return. That means increasing efforts to extract the resource produce progressively smaller amounts. So production declines exponentially because the most easily extracted concentration of the resource become exhausted. As supplies of the resource decline, prices rises. Sometimes it leads to another phenomenon like unemployment, and a number of unpleasant changes happen in the environment, right? So in such situation, the normal way is to switch to another available resources. For example, wood coil oil that was happen in England, where again the bubble occurs until the cycle of unsustainable use is broken to switch over to sustainable use, right? That's why we need to conserve the resources. So then, what is conservation of resources? We know that resources are depleting. Very first, our approach needs to change from a maximizing resource use and short-term gain to long-term economic gain. For example, this can be done in three ways. One is preservation, second is conservation, third is restoration, what has been degraded. Out of these three, practice of conservation is more important as it can reduce the need of preservation and restoration. So, conservation or input reduction by lowering resources is resource use ensures slow depletion of resources, reduce pollution by slowing the flow of matter and energy, and health and monetary benefit. Until we know that recently supplies of most of resources were so abundant that little attention was paid to input reduction, right? As a result, what happened? Depletion rates were very high and the pollution was controlled by scrubber and the form of output or enough of pipe of reduction. So, there are three basic ways to conserve or reduce the need for resources. One is efficiency improvement, second is reuse, recycling, and third is substitution. However, if we look into the resources, so different resources will require different methods of input reduction. When you talk about efficiency improvement, It is generally one of the most effective and economically cheapest method. It is very difficult in one side. For example, it is very difficult to find affordable substitute for water in many of its use, such as agriculture and drinking. So, increased efficiency and reuse, recycling the waste are very common. So, efficiency improvement occurs when the same task is accomplished with fewer resources. So, increasing, for example, increasing the mileage of an automobile from 30 km per liter to 50 km per liter is one of the example, right? Similarly, we are using sprinkler, the irrigation system and so on. Then second, the reuse recycling. When we talk about reuse, it occurs when the same resource is used again. For example, the soda bottle, they may be remelted to make the new bottles or the glass containers. Like improve efficiency, that reuse recycling reduces the depletion of resources and pollution from the resources extraction and use. So, here in reuse recycling is very useful in reducing solid waste, which is very important because landfills are being permanently closed at the rate about 2 per day because of this waste. So, another important process is pre-cycling, which is the reduction of packaging material by manufacturer. It has become one of the more important methods. Like for example, we can use concentrated foods that can be packed in smaller container. So, recycling is not exactly recycling, but it's conservation by increased efficiency. So, the same task is accomplished, but fewer resources are used, right? A simplified recycling schemes, if you look into how we have to recycle, that started with virgin resources, which are the original natural resources that is being extracted. About extractions such as mining, processing, during product manufacture, they usually create pollution, that we know. So, the recycling loop, when we talk about the recycling loop, it begins before the purchased product is discarded. The discard is reprocessed into the same or perhaps another product is produced. As long as the discard is being used in the place of virgin resources, recycling occurs. So, recycling loop is closed when someone buys a product containing recycled material. So, this slows depletion of virgin resources and reduces pollution in two basic ways. Obviously, it reduces amount of solid waste that would have been discarded into landfill, incinerators and other means of disposal. Additionally, if you look into the positive side of recycling, recycling reduces the pollution that would have been produced from the extraction of the virgin resources. But unfortunately, the recycling loop is often not closed, usually due to economic reason. For example, when products made from virgin resources are very cheaper. So, if the cost of product made from the virgin resources were increased to reflect their true cost to the environment, the price differential would disappear and the loop could be closed. Then the third one is substitution. Substitution helps to reduce both depletion and pollution problem. It occurs, when one resource is used instead of another. It helps to reduce depletion because when one resource is being depleted, a more common substitute can be used at a cheaper price. For example, aluminum, a very common metal in the art crust, that can be substituted for much rarer and more expensive copper in making alloys, equipment and other use. So, in the same time, substitution helps us to reduce pollution problem when the extraction, processing and disposal of substituted resources produce less that pollution. For example, many plastic last for 50 to 100 years in the environment before they significantly decompose. And we know that plastic are made of non-renewable resources, that is petroleum. And when trees are renewable, so in that we can use, instead of plastic, we can use paper for different purposes, right, for drinking or food containers and so on. So another is when we are talking reducing the resource depletion, substitution is less desirable than efficiency improvement or reuse recycling. because it has some limitation. So instead of reducing overall resource depletion, substitution often simply switch depletion from one resources to another. So this can be satisfactory if the new resource is renewable or very abundant. The point is depends on the situation. If the substitution is not renewable, it may not be recommendable. And that is the point. Because when you talk about substitution, it also produces the same impact, right? So from that point, what we have studied is, sustainable utilization. In this session is, we know that sustainable utilization may be considered as meeting the present day needs, looking into the present situation of resource crunch, right? Since in every process, when we talk about resource production, resource extraction, every process we produce that produce some waste, but in two forms, either in matter or energy. So we need to emphasize more on pollution prevention, waste reduction, the more efficient use of resources. So today in this session, so what we learn is how we have to understand environmental perspective of energy and matter through different laws of energy and matter, even the energy matter and biological system in very brief, and we talk about resource depletion, that is about matter resources, energy resources, and bubble pattern of resource depletion, and how we have to conserve the different way of conservation of resources. So with this, thank you very much. Let us enjoy the new way of learning. Thank you.